wavelength. Radio waves, number one. Then micro 都才是 infrared。接下来 light ray， 也就是你的 visible light。Next one， 你的 light 的 order 你也是要知道啊。What is the color, the order from left to right？ 是吧？你要背的啊，等下会问你的 wavelength。Red light 的 wavelength 还是 blue light 的 wavelength 比较长？每个人 red light 还是 blue light 的 wavelength 比较长 ？Red 比较长。Okay, so starting from red, R O Y G B I V。OK， 过后这边是 violet 吗？接下来就是 ultraviolet UV、X-ray， 然后就是你的 gamma ray。Okay, so things that you need to memorize are across the spectrum， 从左边到右边，你的 wavelength decreases， 然后你的 frequency increases。speed 呢 ？speed 增加还是减少？从左边到右边。你的 formula 是 B 等于 F lambda， 这个你的 wave 的 formula 啊。所以 frequency 左边到右边 frequency 增加 wave 减少，你的 speed 是 same。全部 wave 都是一样 speed。What is the speed? 3 times 10 power 8 meter per second. Okay, so young speed. So this is before we start the quantum. So you need, this is the one that you we recap. You need to know. Also one thing from your V equal F lambda formula. V 等于 F lambda。V 除以 F 等于 lambda。你的 V 是 constant 来的吗 ？For everybody。所以 1 over F 是 proportional to lambda， 所以 lambda 增加 frequency 增加 lambda 就减少 and the opposite is true. Okay, so this is your radiation. Now we look at black body radiation. 什么是 black body 啊？ What is black body? Black body is anything that, okay, we take down, right? Black body is an object that absorbs and emits all electromagnetic waves or the radiation. Black body is a body that can release or give out all of this. Not only they can release, they can also absorb all of this. So we say black body is an object that absorbs and emits all electromagnetic waves. What is an example of black body? All stars are black body. Stars, your sun. The sun is a black body because the sun, from the nuclear fusion inside the core, it produces all kinds of radiation. Now, 不只是 light 它给你 radio, micro, infrared light, UV, and gamma and X-ray. The sun gives you all of this. Now, 不同 wavelength, 不同 wavelength. This is, maybe this one is radio wave, wavelength 1. This one is microwave, wavelength 2, wavelength 3, wavelength 4, and wavelength 5. Okay, so not only, but when we say light, 当我们讲 light, we generally refer to all of this, not just the visible light. So the sun gives off light is across the spectrum. The sun is a black body. Now, 如果我量那个 sun 在1秒它 produce 多少的 lambda 1, 多少 lambda 2, 多少 lambda 3, 多少 lambda 4. Okay, we call it the intensity. intensity 可以把它想象成 energy per second。energy per second 意思说在1秒，这里我看1秒它 produce 多少 energy lambda 5，多少个 lambda 5 maybe 20%, 30%, 80%. Okay, let's say this one 10%, 5%, 10%, 10%, okay, 35, then you 65% of this. So all add up to be 100. So in 1 second, what is the most produced by the sun? This one. So we say this one has the highest intensity. Okay, highest energy per second. 最多的啦。Yeah, highest intensity is lambda 1. Okay, so the sun we know is a black body. Every black body has a graph. 这个是我们的 radiation curve. Okay, 我放我的 x-axis lambda. So let's say 这个是我 plot for 我的 the sun lambda 1. Let's say lambda 1 is here. It has the maximum, right? 65% of it here. It's the highest. Lambda 2, okay, maybe here. Lambda 3, here, lambda 4. If I plot all the lambda on the graph, then I find there's a typical shape from the graph. The graph looks like a bell curve shape like this. All black body, they show this shape. Okay? But this is unique for the sun. Another star may have a different peak, but the shape is the same. Okay, this is for the sun. The sun, how hot is the sun? How hot is our sun? At the surface, not the center. At the surface is about 5,400 Kelvin. This is at the surface. So 这个 curve 只是 for specific temperature 罢了。如果你的 star has a higher temperature, the graph will be different a bit. The peak will be shifted towards the left side for a higher temperature star. Even higher temperature, the peak will be shifted more to the left. Let's say this is 7,000, just an example like this. Okay, 所以它唯一不同就是它的 peak， 它的 peak 我们叫它 peak wavelength。Okay, peak wavelength 就是你的 highest intensity 的 wavelength. In this case, is my lambda 1. Okay, a hotter star, you will have a peak wavelength that is smaller. Closer to the left side is smaller wavelength. Then the even hotter one, you will have a even smaller wavelength. Okay, so temperature increase, this thing shift to the left side, the peak shift to the left side. 这个是你的 black body curve. Okay, black body 1, 2, 3, depending on the temperature. Okay, 所以我们可以讲不同 temperature 你的 maximum intensity 的 wave 都是不一样的。Okay, so you see our sun, our peak wavelength lambda 1. What is our lambda 1? Our lambda 1 happen to be in the green color. This is the green color. Our peak wavelength is the green wavelength. So where is green color? Green color is in the middle of this one. Green color here. So it means this is green. Then here, if you take all of this, the one near the peak, this is the ROY GBI. 这里 lambda, the range here falls in this line. So all of this color combined is white color. So our sun is white color. It looks white because the peak wavelength it emits the most is the white color. If you compare with the hotter star, let's say this one. Okay, this one is 7,000. Where is the average wavelength? Here, which is shorter, much shorter than this one. Okay, where is shorter wavelength? It's towards the right side. It could be UV, it could be X-ray, it could be gamma ray. 所以可能这一个 star 它 emit maximum wavelength 是在 X-ray。Can you see X-ray? You cannot see X-ray. So if the star peak wavelength is the X-ray, then you cannot see the star. Because the star is emitting, let's say this is the star, is so hot that the peak wavelength is X-ray. So this sun is invisible. Okay? You cannot see the sun, but the sun is there. Okay, so the reason you can still see our sun is because the peak lies in the visible spectrum. And also the reason why some stars appears yellow, some stars appear bluish, is because of the peak lambda. Okay? Right. So the first part is your black body curve. Okay, the black body curve. Now, temperature, remember, T1, 如果他问你 T is T1, they show you a curve T1, T2, T3. The peak wavelength that is the closest to the y-axis is always the hottest one. So T3 greater than T2 greater than T1. Okay, so again, what is black body? Object that absorb and emit all electromagnetic waves. If you plot all the waves on a graph, you get this radiation curve. One temperature, this one. The hotter one will be smaller peak wavelength. Okay, so in quantum physics, what do you study in quantum physics? What you study in quantum physics? So all this time, you study wave. 你有整个 wave chapter， 你的 wave chapter 讲什么？你的 classical physics， 它讲什么 ？Light is a wave. Again, light 这边全部它讲 light is a wave. And then what else? The energy depends on amplitude. What is amplitude again? This is your wave. Transverse wave. Amplitude is the height here. So the higher the amplitude, the greater the energy. 这个是我们一直以来学的吗？ Energy is related to amplitude. So if you have another wave that's taller than this, then you have more energy. Think of it like the water tides. Higher tides, more energy, the harder it hits. Okay, so classical physics explain that energy depends on amplitude. Okay, then what else we learn in classical physics? Classical physics also says, what are the evidences? Classical physics 讲 light 是 wave 嘛，什么证据 ？What is the evidence? Number one, refraction. Number two, reflection. Number three, diffraction. What is diffraction again? 还记得吗？记得 diffraction of wave. 那个 double slit. 你 shine 那个 light 去那个 gap, then the light spread. Then on the screen, you kind of bright, dark, bright, dark, bright, dark, bright, dark. The interference direction. So 你 shine light through the gap, 你不是看到一个点这样吗？ I shine, people at first they think that when they shine the light through the gap, they see a dot on the screen. Because they think the light go through, just make a bright spot, one spot. But it turned out that you don't see this, you see this. Bright, dark, bright, dark, bright, dark. When you shine this. 这个 experiment, 单单这个 experiment 是 prove 了 light 是 wave， 因为只有 wave 才可以做这样的东西，只有 wave 才可以给 diffract， 就是 spread 的意思。OK， 只有 wave 可以 show 这个 nature of spreading。OK， one question。 Okay. Now diffraction, and then the last one, interference. Now all of this is wave nature. Okay. Then after a few years, there's this new thing, quantum physics, that go against this one. Okay. So versus quantum physics. This is the new theory about light. Okay, what does it say? 它讲 ，OK, light 不是 wave 来的 ，light is a particle. Okay, what do you call this particle? They call this particle photon. Okay, now it's an entire new theory. Now we don't think of light as a wave already. We think of it like a particle. So that means, 如果 light travel 在这个方向，你把它想象成你有 particle is moving in this direction. So think of the light ray now as particle like this. And one particle, this is called photon, like a bullet of light that has no mass and no charge. It only carries one energy. One bullet, one package carries energy. This one carries energy. So they call this light particle. How much energy is carried in one packet? Okay, one packet. Okay, now first thing, photon is packets of energy. This is how you think of it. Okay, think of it as package of energy. So then this, they say the energy carried by one photon can be calculated by this formula, E to E, H hat. What is H? This is Planck constant. Basically, the scientists make this formula. So his own formula, he calls it Planck constant. Planck constant is given for you 3.6.63 times 10 power minus 34 is a fixed number 啦。所以这个是 constant 来的吗？不用看它，我们只是 focus 在这个 F 你的 frequency 所以这个 equation 跟你讲，这个 photon 的它 contain 的 energy 是 depend on 你这个 light 的 frequency 是多少。This is different from the previous one. Previous one says what? Energy depends on amplitude. Nothing mentioned about frequency. Didn't mention about frequency. But this one, energy depends on frequency. OK， 那你看啊，这个两个 theory 相撞，因为这一个 theory 讲 energy depends on the amplitude， 意思说这个都有同样的 energy， 只要它的，因为它没有给 frequency 影响嘛，我们知道 frequency 这个全部不同，对不对？可是它这个 physics 讲 energy 是 depends on amplitude， 只要它们全部有一样的 amplitude，then 它们的 energy 都是一样的。只要它们有一样的 brightness， 它们全部的 energy 都是一样的。amplitude brightness。可是 quantum physics 讲，不光是 amplitude， 不光是 brightness 不会影响 energy，energy 只会给什么影响？只会给 frequency 影响。所以 quantum physics 讲，当你从 left to right， 你的 energy increase， gamma 会有最多的 energy， 因为它的 frequency is the highest。You can calculate also. You put it in here, then you calculate the energy of the gamma radiation. Okay, so let's say one example. Let's say we have a light, red light. Red light. Now, think of the red light as photon, so packets of energy. How much energy does the red light has? E 等于 HF。OK， 我们也是知道 D 等于 F lambda， 对吗？这个那 这个我放 v over lambda 等于 f， 这个放进来 h v over lambda。 OK， 所以你有时候可以用这个，有时候可以用这个。这个 v 有时候他们也是写成 c， 这个是 speed of light。 red light 的 energy 是多少 ？Can we calculate? OK， 6.63 10 minus 34 speed of light 3乘12啊。What is the wavelength of red light? 3乘12减7 in meters. Can you find this? Can you calculate how many how much is this? Okay, they will give you wavelength. They give you wavelength, you use this one. They give you frequency, you use that one. Okay, let's see what's the energy red light has. Hơn tiền bạc xứ rồi đợt chiến tự cứu từng đánh nặng dù. Okay, 2.84乘12.9，这个 energy 是总共的还是一个的 ？Remember this one is for one photon only 啊，这个是 energy for one photon. So if I have 5 photons, this one times into 5. Okay, so the energy that you get is the energy carried in one package of the red light. Okay, so higher frequency, higher energy. 如果我用 gamma ray, this one will be higher. This is the quantum physics. Okay, now, so do they just claim it like this? No, they have a proof. Again, you have evidence. Just like your classical physics. What is the evidence? 这个是你的 photoelectric effect. What is photoelectric effect? Okay, so again, now so far we got 2 theory. 这个是 support by 这个 You see all this happening around you. So this is true. This one again is supported by photoelectric effect also. So what is photoelectric effect? Okay. 你拿一个 metal 有 3 electrons. So this, okay? Metal has 3 electrons. Then they make one experiment. First, they shine radio wave. Okay, maybe, okay, we shine another one. We shine red light. They shine red light. Now, classical physics 讲 energy depends on amplitude, 对吗？ Depends on brightness. 所以当它 shine red light 的时候哦，他看到没有 electron 跳出来，一种 energy 没有 transfer 到给那个 electron， 然后它 increase 这个 red light 的 brightness， 因为 brightness 就是 energy， increase 它的 brightness， 它 increase 这个 red light brightness still doesn't come out, the electron doesn't come. Keep on increasing the brightness, doesn't come out. Then what happened is that they switch this one. They switch the red light to higher frequency light. they switch this to UV。OK， 他们把这个换去 UV， 从 red 去到 UV。Then they start to see the electron jump out like this。然后他们做一个 conclusion。当我 increase frequency 的时候 ，electron 才会跳出来。可是我 increase brightness，electron 没有跳出来，意思说 energy 是 depend on frequency。这个是你的 photoelectric effect。Again, so I repeat, they shine red light, nothing happens. They increase brightness, still nothing happens. But when they change to higher frequency, then they immediately see the electron come out. That tells them that the energy is depend on frequency. The energy is depend on frequency. So this observation support the quantum theory. So that is one evidence. And this cannot be explained by the normal classical physics. This one cannot explain this one. So which one is correct? Which one is true? Answer is both. So both they accept one. Because sometimes this one works, sometimes this one works. They are backed by their own experiments. So they accept these two theories. It's just that in different situations they apply different. So these two they accept, then they come up with one conclusion again. 所以 light 是 wave 还是 particle? Which one? Is light a wave or is light a particle? They say we will pick both, we will accept both. Then they come up with the theory of wave, particle duality. OK， 也就是讲你的 light 可以 behave 成 wave， 同时也可以 behave 成 particle. Okay, they call this wave particle duality. Both are correct. 所以 light 可以是 wave， 也可以是 particle 就是 photon 了啊，它可以是 electromagnetic wave 或者是 photon。那 light 它是没有 mass 的对吗？它不是 particle 来的，它是 no mass 的。然后 since they come up with this theory wave particle duality, then they ask another question. 如果 light which is not a particle 它可以是 wave 又可以是 particle， 将 electron which is a particle, OK， 它有 mass 的，它是不是 behave 也是一样？它不是也可以是 wave， 也可以是 particle。 Then they ask this question like this. 如果 light 可以这样子，像我其他的 particle 是不是也是可以这样子？ So they make another experiment now. So far we know electron is a particle, right? Electron is a particle, but can it be a wave? Answer is yes, also. Yes, they found that electron can also be wave. How they found out electron can also be wave? Wave 的 experiment 是什么？ diffraction， 只有 wave 可以 diffract， 只有 wave 可以 spread。 所以它也是用同样的，它用 electron。 They shoot electron to the gap。 这个 gap 很小的 gap， 10 × 12 meter。 It's very, very small gap, smaller than the light. Light only -7. This one -12 because the electron is so small. They shoot electron. They say, okay, if 如果我看到 electron 是一个 strike 这边 ，then 它就是 particle。 可是如果我看到很多个 electron 这边 which is not possible, right? Because we only got one electron. Then it is a wave. So they make this experiment. Then what they found? Now this is the screen. 这个是你的 screen， 这个 screen 是当 electron 一 hit 到，它会发光的，就好像你的 CRO。Okay, so instead of seeing one electron like this, they see a ring of electron like this, like this, like this, like this. That means the electron, when it comes through the gap, it spreads and then strike here, strike here, strike. So you see glowing rings like this. 就很像你的 light 的 bright, dark, bright, dark, bright, dark fringe. Then electron can also be diffracted. Again, you see diffraction. This is a wave behavior. Only wave can have this behavior. Then they convert electron is also wave. So wave particle duality applies for every single particle. 所以现在你有新的 another contradicting theory 啊 ，electron 现在又可以是 wave 哦 ，electron 这样意思说 proton 也可以是 wave，neutron 也可以是 wave，全部 particle 都可以是 wave 吗？啊，可是为什么 proton、neutron 那种我们看不到它的 wave 的 behavior？OK， 所以如果 electron 是 wave 哦，意思说那么 electron 是不是也是有 wavelength？如果 electron 是 wave，这样它是不是也是有 wavelength? Yes. How do you calculate the wavelength of the electron? This is your formula. H over P. You have seen this also, right? 这个是 wavelength of particle， 就是 electron 啦。你可以用这个 formula 来 calculate particle 的 wavelength。particle 的 wavelength。Planck constant 是 constant， 然后 P 是 momentum，h over mv。momentum 是 mass 乘以 velocity。Okay, so what is the wavelength of what is the wavelength of the electron? We can calculate it using this one. You put mass of electron and then you put the speed of electron. OK， 从这个 formula， 如果我的 mass 很大的话，我的 wavelength 就很小。如果我的 mass 很大，我的 wavelength 就很小。你的 wavelength 小，很小很小，小到 negligible， 这样你就会 lose 掉这个 wave 的 behavior。That's why you have huge mass. That's why you don't act like a wave. You cannot diffract. Only electron you only see electron wave nature. The reason is because electron has a very small wave, very small mass. Electron 的 mass 很小很小很小，所以它的 wavelength is significant. That's why you can see the diffraction here. Proton 你看不到它的 diffraction，proton 太重了 ，neutron 也是太重了，只有 electron 你可以看到它的 diffraction。Okay, so 你的 wavelength 是 affected by 你的 mass. The larger your mass, the smaller your wavelength. Then you don't have the wave behavior already. Okay, so this formula for you to calculate particle wavelength. They have a name for it. They call this de Broglie wavelength. De Broglie wavelength is the particle wavelength. Okay, you take a break. Now you take down the temperature. Okay, the break, then you continue with the 2C. This one A. For black body, okay, object that absorb and emits all EM waves. E. 5. Emit by hot bodies are called black body radiation. 5 going. Question 6. Classical physics not consistent with the result. What does the result show? The result is the black body curve, right? So it shows that 当你 decrease wavelength 的时候，你的 energy increase，然后 U decrease。这个是你的 experiment result show 到的。Okay, 你 study 那个 black body, the sun, okay, the sun, and then you plot this curve. You see that as the wavelength decrease, the energy increase and decrease. That's your quantum theory. Okay, because quantum theory says that the energy depends on the frequency. Okay. 可是 classical theory 讲你的 energy depends on 不是 frequency 啊，它讲你的 energy depends on your amplitude. Okay, so the study is not consistent. C is the answer. Increases that and then it decreases discontinuously. Okay, 当你的 wavelength decrease 的时候。7 is photons, C. Okay, number 6 is C, 7 is C. Question A. Now, the hottest one should have the smallest peak lambda. Okay, so hottest is T3, followed by T2, and then T1. Donkey. 8 is donkey. Number 9 is boy. What is the energy radio have the frequency of Planck constant? Okay, so E equals to HF. Answer is boy. Number 10. Number 10, how do you calculate this? You're given wavelength. Okay, 你的 formula 你的 E 等于 HF。如果它给你 wavelength， 你就用 E 等于 HC over lambda。那对不对？那记得啊，你的这个 energy 你算到的是 for 一个 photon 罢了 ，only for one photon. Okay, you plug in the values, you find one photon. 然后他讲 the number of photon is 3.32 times 10 power 18 per second. 3.32 times 10 power 18 photons per second. Okay. Power 是 energy 除以 time. Power is basically energy per second. 所以你算你的 energy for one photon 乘以你的 photon, that's the total energy in 1 second. That is your power. Answer is C. 1.2 watts. 1.2 watts. Okay, 这一题两个 star X and Y, one is red, one is yellow. One appears red, one appears yellow. Which dwarf star has a higher temperature? Now remember we said the color of the star depends on its peak wavelength. Okay, so which one is hotter? So the hotter one should have a smaller peak wavelength. So red or yellow, yellow is smaller wavelength. Yellow is hotter. So C or D, yellow light is hotter because it has a higher frequency. C. Okay, so same reason, for the same reason why blue stars hotter than red star. Blue star has a smaller wavelength than red star. The reason why the star appears bluer is because the peak wavelength falls in the blue color. Compared to red star, the peak wavelength falls into the red color, so it appears red. So the color that you see is the peak wavelength. Okay. Question 12. Which is the evidence of quantum physics? photoelectric effect，还有一个就是 line spectrum。line spectrum 是讲什么 ？line spectrum basically 它就是讲你的 electron 只可以 absorb specific energy 罢了。这个是你的 nucleus。This is your electron. You got shell 1, shell 2. The higher the shell, the more the energy. 你的 electron 只可以 absorb specific energy. Let's say 它只要5 joule， 它才可以跳上去这边。所以你的 photon 那种 photon 不是5 joule 的 photon，let's say 有一个 photon 来，这个 photon 是10 joule， 它就会 skip 它。Nothing happens. Then you have another photon coming and 8 joule. Again, it will skip it. When the photon is exactly 5, matches this one, so very specific matches this one, then only it can absorb and rises. So this proves that, or this supports that light is a photon. Okay, light is made of photons. Light is made of specific energy with photons. Okay, so this is another experiment that supports the quantum theory. So again, the quantum theory says light is a particle of photon and it carries specific energy. Not like the classical says light is a wave, it carries continuous energy. 因为如果它是 wave 的话 the wave can go in, okay, doesn't matter what energy it needs, 5 joule, okay, the wave can still, it can absorb here. But the photon, when it's not matched, it will still. Okay. We go second part. Okay, now, 看这边先 after this, you can rest. Okay, because this one is very important, this part. Work function, threshold frequency, and your threshold wavelength. Okay, let's say I take a metal, 3 electrons. Okay. So I take a metal with 3 electrons and then I shine a light. I shine the light, this I shine UV light. Okay, so think of the light as a particle. So now I will draw photons of UV incident on the metal. Okay, so let's say we'll emit 那个 electron or release 那个 electron. So you're going to need energy to release the electrons. The one at the surface is the easiest to release because it's the closest. So let's say you only need energy, you only need 50 joule to release. The second layer, you need higher energy because you have to send it to the surface, then only emit. So maybe this one you need 100 joule, and then the third one, the deeper the layer, the harder you release it. Okay? 所以这种 energy 是你需要的 energy 来 release 它，你需要的 energy 来 release 它。Okay, so depend in 你的 photon， 你的 photon E 等于 hf。Okay, so let's say your photon energy is 25. So everybody is 25. Can you release the electron? Cannot, not enough. Okay, not enough, then all the photon will just skip. Nothing happens. Falls on it, nothing happens. But if I shine again, I increase the frequency of the wave, and now my photon, each one is 50 joule. 50 joule, 50 joule. 一个 photon 只可以给一个 electron absorb. Okay, 一个 photon 只可以给一个 electron absorb. So when this photon comes in, then absorbed by this electron will be released into the atmosphere out of the metal. Now 50哦，它需要50 release 对吗？你给它准50，这样它跳出来以后是它的 balance， 它的 leftover energy is how much? 0 joule. So it jump out and then it just stay there, do nothing, because no more energy left already. So this again, this come here, then release another one. So 2 photon comes, you release 2 electrons. Now let's say now I give it more energy. This time I shine higher frequency light again. So now my photon, each one is 100. Let's do 125. Okay, 125, 125, 125. Okay, this photon, let's say this photon absorbed by this one. Can it emit? Yes, it can jump out, but it only needs 50. You are giving it 125. So you take 125, you minus the one needed. How much left? It has 75 joule. 这个75做成它的 kinetic energy. OK? Again 你给它125，它只需要50来 emit 嘛，所以你扣掉它，你剩下的是做成它的 kinetic energy. So let's say this photon comes and hit this one. 那125你只需要100来 release 它。So let's say you release this one. How much kinetic energy it has? You minus this one, again you got 25 joule kinetic energy. OK， 所以如果你给它刚刚好，它出来的时候它就没有 kinetic energy。如果你给它 extra， then when it is emitted, it will have kinetic energy. So all the photon comes absorbed by all the electrons. Let's say all the electrons emit. 哪一个 electron 是会有最大的 kinetic energy？ 一定是最上面的那个 layer。你 compare 这个 electron， 它有75，可是 deeper the layer, the less kinetic energy they have. 所以一定是那个 surface 的 electron that acquire the highest number of the highest value of kinetic energy. OK， 因为它们只需要最少的 energy 来 be released. OK， work function 是你的 minimum energy needed to release the electron. 50、100、150， 50是你的 work function， 这是你的 work function. The minimum energy you need is 50 啦 to release it. 你的 symbol 是 capital W， 所以你的这个 metal 的 work function 是 50 joule. Now from here 我们写一个 expression， 你的 kinetic energy EK electron 的 kinetic energy 是你给它多少，这个是 photon 的 energy， 扣掉它需要多少 energy 你的 to be released. Okay, 你的 kinetic energy 就是你给它多少 So let's say this one, you give it 125, it only needs 50. So how much is your kinetic energy? 75. So this is your expression. How much kinetic energy we get is how much we give it minus how much they need. 如果我要 maximum 的 kinetic energy 呢 E K max maximum 的 kinetic energy 就是你的 photon energy 然后你扣掉这个 energy to be released we take the smallest energy to be released the work function 扣掉你的 work function then 你的这个是 maximum kinetic energy 那125来 absorbed by the first layer 75 kinetic energy you have. If absorbed by the second layer, then only 25 kinetic energy you have. So your maximum kinetic energy is the first layer. That's why how I get this equation, Ek max is photon minus your work function energy. Okay. So you have to remember this equation because in all calculation, you use this one. Okay. Now, photon energy Ek max 等于 HF. Okay, 你的 formula HF 减掉 work function. This one become this one. Okay. I will write here Ek max 等于 HF 减掉 work function. Okay, let's say I make a graph of Ek max against frequency. 你做你的 y 等于 mx plus t. Y axis, x axis frequency. Then you'll see your y-intercept is minus w. It will be a straight line graph. Crossing. Here is your w. This is your graph. You have one graph in this part. Okay. What does the graph tell you? This graph, 如果你给它 let's say 你给它 frequency 1. This incident radiation. 你可以从你的 graph 找你的 maximum kinetic energy 多少 frequency 2. 你可以找你的 maximum 的 kinetic energy. 如果你给它刚刚好 this frequency, what is your kinetic energy? 0. What is this frequency? This is your threshold frequency. 你给它 F1, 你的这个 frequency 是你的 frequency of incident wave 啊，你的 incident radiation 就是你 shine 什么 UV light, red light, blue light, what frequency is that? That is the incident. So if you shine, let's say high frequency, okay, this is how much kinetic energy of the electron you get. If you shine a radiation that is same as the threshold frequency, then this is 0 kinetic energy. You don't get any energy from it. Okay, so this graph, you need to remember the graph. The line shows metal, this metal 1. 如果我拿另外一个 metal, then 你会有另外一条 line. This is metal 2. Gradient 一定是一样的。为什么？因为 gradient 是你的 Planck constant. 你的 gradient 是 a constant value. So it doesn't matter metal 1, metal 2, metal 3. It will have the same gradient. So all the lines are parallel like this. This is metal 3. Okay, metal 3 它的 work function, metal 2 they have different work function. 不同 metal 有不同 work function 啊。Some metal you need more energy to release it, so they have a higher work function. Some metal they have lower work function. Okay, so formula that you need is this one. Emax 等于 HF 减 W. Okay, let me label it 1. And also 如果我拿这一个 point, okay, point A, at A y 等于0 ，OK， 你的 Emax 啊，你的 Emax 等于0，然后你的 F 等于 F not at point A 这边。如果我 sub 这个 point 进去我的 formula，then 0等于 H F not 减 W。这个我搬过来 W 等于 F not。This is another formula. This is your work function formula. Planck constant 乘以你的 threshold frequency. This is your number 2 formula. Okay. Formula number 1, formula number 2. All this you need in your calculation. W 等于 HF not 我也可以写成 WHC over lambda not. Threshold frequency, then 它的 wavelength 就是 threshold wavelength. This can also sub inside here. HF 减 HF not. So 1, 2, and equation 3. Okay, I will stop here. You tired already? Yes. Really. De Broglie wavelength. De Broglie wavelength 是 wavelength 等于 h over e。这个是讲着 particle 可以 behave 成 wave， 就很像 electron 可以 behave 成 wave， 然后它的 wavelength 要怎样算？它的 wavelength 是用这个 formula 来算啊，这个是用来算 particle 的 wavelength。So from 刚才的 quantum physics 我们讲到 light 可以是 particle 也可以是 wave， 同样的 electron 也可以是 particle 也可以是 wave。所以 electron 的 wavelength 可以这样子来算。OK， 这个是 Planck constant， 这个是 momentum，OK，wavelength 等于 h over mv。那 from 这边我们看到的，如果你的 mass 越大 ，then 你的 wavelength 越小。So the question is asking proton, hydrogen, electron, and helium nuclide particles of different masses. If these particles have the same kinetic energy means they have the same speed. And this is also the same. Okay, same speed, same kinetic energy. Which particle has the greatest de Broglie wavelength? Which particle has the greatest wavelength? Of course, the one that is smaller has the greatest wavelength. So we look for the one that is smallest mass, which is electron. See, smallest mass. OK， 你做完到20啊。